Hi there. This video is for pre-calculus lesson 4.1. I'm just going to zoom in a little bit here. Probably might want to have a calculator at hand, but you can always also pause the video. So we're talking about radian and degree measures in this section. So most of this, I would say pretty much all of it, should be review. So we're going to remember how we draw angles, use radian measure, and convert between radian and degrees. I'm going to skip a lot of these and get to kind of the important stuff so this video isn't too long. This is how an angle is defined. Two rays, and we call that point the vertex. Mostly what we will be looking at in this class, or in this section though, I guess I can say class also, is angles on the unit circle, or you can think of them on the coordinate grid. So they're always going to start on the x-axis, and then they're either going to go up if they're a positive angle or go down if they're a negative angle. So this is always going to be your initial side, the side along the x-axis, and where your angle ends is your terminal side. That point right there is the vertex, and the angle is right in here, which often we use the Greek letter theta. So this is reminding you when you start at your initial side, which is kind of the right side of the x-axis, and you go down, that angle will have a negative measure. If you start at your terminal side here and you go up, that angle will have a positive measure. Here it's just telling you the different Greek letters that they use for labels: alpha, beta, theta. Okay. First thing we're going to talk about is radian measure. So radian is just a different way to measure an angle. So what you're used to is measuring the angle right down here close to the vertex. Radians measure the angle by measuring the distance of this arc. So the measure of an angle is determined by the amount of rotation from the initial side to the terminal side. One way to measure angles is in radians. This type of measure is especially useful in calculus. Actually, in calculus, we are all radians. We never use degrees. So what they're doing is they're taking the full circle and they're dividing it into sections. That would be the measure of this length. All right. Now, they have this formula. They give this formula to you in the book. Theta equals S over R. So S is equal to the length of the radius of the circle. I don't think it's important at all to remember this. What you do want to remember is that when you have a radian measure, it does not have units. So a radian measure will always have the pi in it. So like pi over 2 or pi. No units. I almost think of the pi as the units. Whereas degree, you have to have that degree symbol. So pi over 2 is 90 degrees. Pi is 180 degrees. One full circle is 2 pi. That's why they have 2 pi r here. So one full trip around the unit circle, so here all the way around, is 2 pi. One full circle in degrees is 360. So if you think of taking the full circle and dividing it into 1, 2, 3, 4 pieces, this first one would be pi over 2, 2 pi over 2, which would simplify to just pi, 3 pi over 2, and 2 pi. Hopefully most of that you remember. This is where the PowerPoint does a cool thing and shows you the measure of an angle, but this is a video, so we don't have that. Just a reminder of your coordinates. This is coordinate 1, coordinate 2, coordinate 3, coordinate 4. So this tells you in coordinate 1, your angles are greater than 0, but less than pi over 2. If you rotate up to here, the measure angle is pi over 2. So every angle in here is between 0 and pi over 2. Every angle in quadrant 2 is from pi over 2 to pi. So 180 degrees, this is 180, this is 90. 180 degrees is the same as pi. So every angle in quadrant 2 is greater than pi over 2, less than pi. Every angle in quadrant 3 is greater than pi, less than 3 pi over 2. And then all the way around is 2 pi. So quadrant 4, all the angles are greater than 3 pi over 2 and less than 2 pi. Again, pause the video to get this information in your notes. All right, let's go to example 1. So I would pause the video to write the example. The directions say sketching and finding a coterminal angle. Oh, I thought somewhere we defined coterminal. Did I skip that slide? Guess I didn't. We're going to do it while we do the example. Okay, find one positive angle. Theta equals 13 pi. Oh, sketching and finding a coterminal angle. Find a positive for the positive angle, 13 pi over 6. Subtract 1 to find the coterminal angle. This doesn't really say, oh, I guess it's kind of telling you what to do while you're doing it. So I'm going to do a little diagram over here to show you what coterminal angles look like. If I draw an angle here, it's going to be a positive measure angle. I could draw a negative measured angle that had the same terminal side. So coterminal angles have the same terminal. I guess I should have said initial first. Initial and terminal side, but different measures. So coterminal angles have the same initial and terminal side, but different angles. So it could be one positive and one negative. These are two different angles. This is a negative angle. This is a positive angle. They're coterminal because they have the same initial and terminal side. It could be two positive angles. So this could be my first positive angle. And then if I start here and I go all the way around and then back to that same terminal side, these are two different positive angles with the same initial and terminal side. So they don't necessarily have to be one negative and one positive. So here it says for this positive angle, 13 pi over 6, 13 divided by 6 is greater than 2. So this is going to be similar to the one I drew here, where I go all the way around and then I go a little bit more. So I'm trying to find that little bit more. So they actually have it drawn here. I'll use this. So this is 13 pi over 6 all the way around and then a little bit more. So what they're asking me to find is what is that little bit more? So all the way around is 2 pi. This is more than 2 pi because if I divide 13 by 6, I get a number greater than 2. So this is more than 2 pi. So to find that little bit, I want to take 13 pi over 6 and subtract 2 pi. And you get pi over 6. So 13 pi over 6 and pi over 6 are coterminal angles. Now, if you had to do this without a calculator, you would have to get a common denominator here. So the common denominator would be 6. So I would multiply the top and bottom of this fraction by 6. When I do that, on the top I would have 13 pi minus 12 pi all over 6. 13 pi minus 12 pi is 1 pi all over 6. So make sure you can do that without a calculator. Sketching, coterminal, and this is part B. They're all example 1, part B. So this says for this positive angle, we want to find a coterminal angle. So theta equals 3 pi over 4. That's here. And then if I want to find a coterminal angle, this is less than 2 pi. So what I want to do here is I want to take 3 pi over 4 and subtract 2 pi. And I get negative 5 pi over 4. So if the given angle is less than 2 pi or less than a full circle, you're going to take that angle and subtract 2 pi. The one we just did, the angle was greater than 2 pi. I guess we still did the same thing because we were getting another positive angle. So remember, coterminal angles, you can always add or subtract 2 pi to get a coterminal angle. So for a positive angle, subtract 2 pi. All right, now in part C, we're starting with a negative angle. So we're starting down here. If I'm starting with a negative angle, I want to add 2 pi. So if you're starting with a positive angle, we want to subtract 2 pi. If we're starting with a negative angle, add 2 pi. So we have a negative angle here. So negative 2 pi over 3, we want to add 2 pi. Again, this would be possibly a non-calculator, so make sure you can find that common denominator and do that addition. What you get here is 4 pi over 3. So 4 pi over 3 and negative 2 pi over 3 are coterminal. So this is the one they gave us. The negative all the way around is 2 pi. So I basically want to subtract 2 pi to get the other part of my circle. All right, so coterminal angles. Same initial and terminal side. Add or subtract 2 pi to get a coterminal angle. These are some your turns for you to try. Pause. Oh, there's the answers. Shoot. Pause the video and then check the answers. So this says determine 2 coterminal angles, one positive and one negative. So remember, you're going to add 2 pi or subtract 2 pi. If you add 2 pi and you get another positive angle, well, that will be your positive. If you subtract 2 pi and you get a negative angle, then you're done. You have one positive and one negative. Say you subtract 2 pi and you still have a positive angle, then you can subtract 2 pi again. So you can add or subtract 2 pi as many times as you need until you get one positive and one negative angle. So depending on the given angle, you might have to add or subtract 2 pi twice to get one positive and one negative. The other thing is you could get different answers. If you think about it, there's an infinite number of coterminal angles. You can just keep going around and around the unit circle. These are probably the most obvious ones that you would get. So try adding or subtracting 2 pi until you get one positive and one negative angle. See if you get those. Okay, the next section we're going to switch over to degrees, which is the one that you're probably a little more familiar with. So here is kind of unit circle, which you're used to. And we're divided up into degrees here. Now, the one thing we want to be able to do is we want to be able to convert back and forth between radians and degrees. This is really where our conversion comes from. The fact that 180 degrees is equal to pi. So we kind of use this angle right here to write our conversion formula, if you want to call it that. I'm just going to go right to this. So this tells you To convert degrees to radians, multiply by this ratio, pi over 180. To convert radian to degrees, multiply by the ratio 180 over pi. Now, I'm going to say you don't really have to memorize these. What you want to do is what you want to end with. So say what you want. Goes on top. That's what I say, and I'll show you how that works in a second. So say I'm given degrees. For example, if I'm given, I don't know, I'll give a weird number, 43 degrees, and I want to convert to radians. I choose the ratio that has radians on the top. Here's why. Oh, this is multiply, by the way. The degrees cancel, and my answer will be left with radians. Say I'm given radians, pi over 4, and I am told to convert to degrees. I'm going to multiply by the ratio that has degrees on the top. And then my pi's will cancel, and I'll be left with degrees. So you don't really need to memorize this whole thing. Just remember whatever you're converting to or what you want at the end is what goes on top. So if you want radians, you multiply by the ratio with radians on the top. If you want degrees, you multiply by the ratio with degrees on the top. All right, let's look at one. Example 2 here. Says converting from degrees to radians. So I want radians. So I'm going to multiply by the ratio with the pi on the top. Think of the pi as your radians. So, oh, this work's done here. I'm going to redo it. So I'm starting with 135 degrees. I want to convert to radians, so I'm going to multiply that by pi over 180. And then my degrees cancel, and I'm going to be left with pi. I'm looking for my example. Now you can put this in your calculator and simplify the fraction, and you would get 3 pi over 4. So 135 degrees is the same as 3 pi over 4. 540 degrees is what I'm starting with. I want to convert it to radians. Multiply by the ratio that has radians on the top. My degrees will cancel, and I will be left with 3 pi. So this is bigger than 360. So you should end up with a radians that's bigger than 2 pi. So do that little, does this make sense? Check. Okay, these are your turns. So pause the video and try these. Again, we are starting with degrees and we are converting to radians. And this says do not use your calculator. So you're going to have to simplify that fraction on your own without using your calculator. Okay, this is what you should have gotten. Hopefully you paused the video and tried that. 5 pi over 12 and 16 pi over 9. All right, now, example 3, we're doing the reverse. So we're converting radians to degrees. So we want degrees when we're done. So we're going to multiply by the ratio that has degrees on the top. Okay, negative pi over 2 radians times 180 degrees over pi. Now my pi's will 1 out. They'll divide to give me 1, which should happen. So I'm left with negative 180 degrees over 2 or 90 degrees. Now hopefully you might have even known this one without doing the conversion. Negative pi over 2 means I start here. I go 90 degrees down, so that's negative pi over 2, because up here is positive pi over 2. Okay, 2 radians. So 2 radians. It's weird. It doesn't have the pi in it. I'm still going to multiply by what I have there. So I'm going to get 360 degrees over pi. So this is like pi, the number in your calculator. This is going to be approximately 114 degrees, 0.59. So this obviously is a calculator problem. I mean, you could leave your answer like this if it were non-calculator, but to get the full degree measure, we want to use the calculator on that one. So when they started with the 2 here, they already multiplied it by the pi. So that's why it looks a little different. Most of the time, you'll be converting an angle that has the pi in it. Okay, couple of your turns. Pi over 6. Convert that to degrees. These say do not use your calculator, so you'll get nice round numbers for these. And 5 pi over 3, convert that to degrees. And you pause the video. That is what you should have for your answer. Okay, then one last thing, complementary and supplementary. You probably remember this from geometry. So 2 positive angles are complementary. So I would just put this in your notes. Complementary when their sum is 90. Or remember, or pi over 2, which is the same as 90 degrees. Supplementary when their sum is 180, or pi. All right, let's look at an example. It says, if possible, find a complementary. So I'm going to write right above here. Sum is 90. Oops, there we go. Supplementary, sum is 180. I don't have a ton of room here, so I'm going to draw a little line. You can spread it out in your notes. 72 degrees is less than 90, so to find a complementary angle, I'm going to do 90 degrees minus 72 degrees, and I get 18 degrees. So that's my complementary. I'm just going to label it complementary. My supplementary, 72 plus something equals 180. So really, I am solving this equation, 72 plus x equals 180. And then I would minus 72 from both sides. So x equals 108 degrees. That is a supplementary angle. All right, 148. Well, this 148 is greater than 90 degrees. So I can't add anything to 148 and get a sum of 90. So this has no complementary angle. Supplementary, I can do 180 degrees minus 148 degrees, and I get 32 degrees is my supplementary angle. Okay, I'm going to draw a curvy line here. So this is same deal, but it's in radians. So remember, radians is pi over 2 for 90 degrees, and it's pi for 180. So if I want a complementary, I want to say pi over 2 minus 2 pi over 5. I need a common denominator here. The common denominator would be 10. So multiply the top and bottom of this fraction by 5. So I would have 10 pi over 10 minus multiply top and bottom of this fraction by 2 minus 4 pi over 10. So that's going to be 6 pi over 10. And you, of course, need to simplify that. Pi over 2 minus 2 pi over... did I do that right? 5. No, this should be a 5. I have a mistake there. Sorry about that. Fix that in your notes. Go back. Hopefully you already caught that when you were watching this video. 5 pi minus 4 pi would be pi over 10. So that's my complementary angle in radian measure. Supplementary, I want to take pi, which is the same as 180, and minus 2 pi over 5. This time my common denominator will be 1. So I'm going to multiply the top and bottom of this fraction. I'm sorry, my common denominator will be 5. So I'm going to multiply the top and bottom of this fraction by 5. So I'm going to have 5 pi over 5 minus 2 pi over 5. 5 minus 2 is 3. 3 pi over 5 is my supplementary angle. Okay, I got one more here, 4 pi over 5. I'm just going to do this on a separate piece of paper. So 4 pi over 5. Now, 4 pi over 5 is greater than pi over 2. Let's see. You can think of pi over 2 as 1/2 pi, and then 4 pi, oops, trying to turn on my calculator here. And of course, it doesn't want to help me out. 4 over 5 is 0.8. Oh, that's hard to see. 4 over 5 is the same as 0.8 pi, and that's greater than 0.5 pi. So this would have no complementary angle. I'm using this for angle. Supplementary, I want to do 180 or pi minus 4 pi over 5. Get a common denominator, that would be 5 pi minus 4 pi over 5, or pi over 5 is my supplementary angle. Okay, I think then there are a couple for you to try. 1 degree and 1 radian. So find a complementary and a supplementary for 36 degrees. Complementary and supplementary for pi over 6. So remember, complementary sum is 90 degrees or pi over 2. Supplementary sum is 180 degrees or pi. So pause the video, try those, and there are your answers. That is it for this lesson. You should now be able to do your 4-1 homework.